Today we're going to do a tear down of this transformer. On the secondary side of the transformer we've got 30 volts at 3.4 amps. Now if you look closely you can see that there's a little packer in here. Pliers make great hammers. Now that we've shifted this little packer out of here, I expect these laminations will just fall out. This is what's called E and I laminations. You can see that some laminations make up the letter E and some make up the letter I. It creates a shell around our coil for the magnetic path. And you'll notice the center portion of the core is twice as wide as the beam, so that generally speaking the cross-sectional area of the magnetic circuit is the same throughout the whole circuit. And there we have our former. There we go. Some people refer to this outside layer as elephant hide. It's just a paper-based tough material impregnated with something to make it harder. It's to protect the windings on the former. And then we have what appears to be packing tape around the outside, but it isn't packing tape. It's actually stuff called mylar. Mylar can handle much higher temperatures. You've got to remember the transformers sometimes get hot. That's the low voltage on the outside, and the higher, still low voltage, or extra low voltage on the outside, and low voltage on the inside. Now before I start tearing this to pieces, what I would like to know is how many turns there are. On the outside we have 1, 2, 3, 4. Each layer has about 32 turns on it. 32 turns, just in case I lose count. 1, 2, 5, 11, 55, 41, 48, 48. So we've got to 48 turns. 48 turns to the tap. 49, 62, 77, 95, 55 turns. Half of 95, 48. The 48 is a center tap. We know that this was a 30 volt transformer. We know that we had 95 turns on the low voltage side of the transformer. So from there, because we know that the turns ratio and the voltage ratio are the same, we had 30 volts equals 95 turns. 1 volt equals 3 turns. So we have another layer of another torn layer by the look of it, another layer of this heavy, thick insulation, and once again more mylar. You can see just looking at this that this cross-sectional area of the wire is considerably smaller than it was on the secondary side, and that's because it's carrying less current. Now you might think, looking at the size of the conductor on this secondary, that it's way overrated for 3 amps. But in fact, you've got to remember that all these turns are bound up together and the heat is going to build up inside the transformer. So the wire needs to be much larger size to cope with that type of current when it's all bound up and the conductors are running in parallel with each other. After unwrapping my transformer, I've decided to use the same wire again. Saves me buying new stuff. I think this will do the job. It'll be rough like gunsparky normally does, but it'll do the job for my purposes. What I want to do is rewind this so that instead of just having 15 volts and 30 volts, I want a variety of voltages. So I can just choose how many turns I want to decide what voltages I want. And I've decided to go for 0 and 30. Of course, that was the original transformer. I already had a tap at 15, so I'm going to put in another tap at 12 volts and another tap at 24 volts. This will give me 3 volts if I connect between these two terminals. It'll give me 6 volts if I connect between these two terminals. It'll give me 9 volts if I connect between these two terminals. It'll give me 12 volts between these two terminals. It'll give me 16 volts between 12 and 30. Sorry, that's 18 volts. And of course, it'll give me 24 volts between 0 and 24. I don't have any of this tape new stuff, so I'm just going to use the old stuff that we took off. Wrap that around. Put our mylar on. Now this is by no means going to end up perfect. And one of the problems with doing this the way that I'm doing it is that these windings are not going to be as tight as they otherwise would be. I don't have any mylar tape, so I'm going to reuse the stuff that was on here before. I'm just going to use a bit of masking tape. Now, masking tape is not ideal. However, as long as this doesn't get too hot, it shouldn't be too much of a problem. I'm not going to be able to wind this as tight as I'd like to. The problem with not winding it tight is the windings will rub up against each other and wear the insulation out. So this transformer is not going to last forever, but it'll do for my purposes. I also don't have a winding machine, which is going to make life a little bit difficult. Now you may be wondering, does the direction matter? And the answer is, well, no. So I'm just going to lay this up as neatly as I can. I've wound on 36 turns to give us 12 volts. And I've stopped a little bit short of where I want to bring my wire out. So I'm going to solder on a tap so that I'll be picking up 36 turns, and that'll give me 12 volts output of this transformer. But I'm still going to have to put in some robust insulation, masking tape. Not perfect, but better than nothing. And we'll lay that in there. Now I need to start counting again. And of course, my next count after here is another 3 volts. So I'm up to 36, and I've put on another turn, so I'm up to 37. 15 would be 45 turns. So I need to get to 45. I'm up to 37, 38. And here's my 15 that was already on there, my centre tap when I started, right where I want it. And we may need to insulate that from the rest. So we're up to 15. I need to count on another 9 times 3 is 27 turns. 1, 2, 18. We're up to 27 turns. Now we should have 6 times 3 is 18. We should have 18 turns to the end to give me 6 volts. 9. Well, the disappointing thing is I only counted 17 turns, so I've lost a turn somewhere. But 17 is going to be a fraction under 6. That'll be fine. That's good enough for me. I've already discussed that I've been using masking tape, and masking tape is certainly not ideal. What I do have is glass tape. Now it's time to load our laminations back into our transformer. Jam that sucker in. My favourite hammer. On the line side, we've got 237 volts. On the low voltage side, we'll test between one leg and the other, and we have, it's 30 volts. Going to that centre tap, we should have 15 volts, and that's pretty close. We look at the other one, we've got 15 volts, pretty close. I'm going to use that 15 volts as my reference point. I should be able to find a 3 volt and a 9 volt. So we go from the centre tap to here, and we've got 3 volts, correct, and we should have 9 volts. We've got 8.8. That's a little bit under, but they're all a little bit under, so that makes sense. That'll be my 6, a little bit low, and that'll be my 24. The other leg, that was the 12, 18 on one side, 12 on the other, 11.4. That's consistent with everything else that we've done. So there we have, we've stripped down a transformer, calculated the turns ratio, which turned out to be 3 turns per volt. We counted in, we pulled apart the laminations. You might have noticed that the laminations were coloured, and that's because there's a coating on them to insulate them from each other to avoid eddy currents. If we didn't have, get that off there. Yeah. If we didn't have laminations in here, we'd get cycling currents cruising through there.